Hello student, welcome to our fourth lesson, which is our last lesson. And in this lesson, we are going to look at the circle. Now, the total length of the outline of a circle is called circumference. When you go round the circle, that one we call it the circumference. But any part of the circumference is called an arc. Then, if the arc length is more than half the circumference, it is called the major arc. And if the arc length is less than half the circumference, is called the minor arc. Now, the region enclosed by the two radii and the minor arc, we call it the minor sector. And if we have the region that is enclosed by the major arc and the two radii, we call it the major sector. Now we have it here. We have this loud, the outline is our circumference. This part from here to here, from A to B, which is part of our circumference, we call it an arc. And because now this arc is less than half of the circumference, we call it the minor arc. Then this region that is covered by the two radii and the minor arc is what we are calling the minor sector. Then from here, A, we move to the other side. This length or this part is more than half of the circumference. Therefore, we call it the major arc. And now, this region that is covered by the two radii and the major arc, then we call it the major sector. So those are the parts of the circle that we are going to consider when we are looking at the circumference and the length of the arc. Then from there, we move to the circumference of a circle. We have seen that when you go around that circular object, that is what we call the circumference. And now, for us to come up with the formula of getting the circumference of the circle, we need to do several activities. We are supposed to correct circular objects. Using a thread, we get the length of the circumference. Then from there, we can be able to get the diameter. And for you to get the diameter, you just need to place the circular object using your set squares. Then you can be able to measure between them, or you can be able to measure the length between the two set squares when the circular object is in between. Now, we did that, and we were able to get the diameter of 4 objects and their circumference. Then from there, the last column, we divided the circumference with the diameter. And by so doing, we found that this first value, if you divide, this will give you 3.144. That is, we are getting the circumference 19.18 divided by the diameter, which is 6.18. Then in the second one, you have 14.77 divided by 4.70. And when you do that, all these values, you find that the last term here is almost the same. This is 3.144, 3.143, 3.144, 3.146. This value is a constant. And we have seen that after dividing the circumference by the diameter, the values were found to be almost a constant. All they are the same. They are not changing. And this number, we call it pi. And it is represented by a Greek letter pi, this one. Now, from this experiment, and I'm sure that you can do it at your home, you can get circular objects and get the diameter and get the circumference, and then you divide. When you do that, you'll find that this term is equivalent to 3.144 or 3.142. So pi is given by the circumference divided by the diameter. That is C over D is equals to pi. From here, you want to get the circumference, so you multiply through by D. By so doing, you get that the circumference is pi D. Since radius, we know that the radius of a circle is twice diameter. I mean that the diameter is twice the radius. So it implies that the radius is D, that is the diameter, divided by 2. So we can replace where we have the diameter, you can just say that diameter is twice radius. Then the circumference will be C, or the circumference is pi d, but d is 2r. Therefore, the circumference will be 2 pi r. So you can either use circumference as pi d or 2 pi r depending on the values that are given. But I'm saying it is possible to get this value of pi. But in our case, we've seen that pi can be 3.142. You can see that it is close to what we have found, or 22/7. I'm sure this is not a new term. So our pi will be, we are going to use 22/7 or 3.142. Then from there, we move to an example or several examples here. Find the circumference of a circle whose diameter is 14 centimeters. We proceed as follows. Circumference is pi d. So pi is 22/7 times 14. Here you can cancel by 7, 1 by 7, 2. You get that it is 2 times 22, you get 44 centimeters. Then number 2, find the circumference of a circle if the radius is 5.6 centimeters. Again, we now use the second one. Circumference is 2 pi r because we are given the radius. So you have 2, then pi, then times r. Again, when you divide this, it will give you 0.8. And when you multiply all this, you get that it is 35.2 centimeters. From there, we can move to another term, length of an arc. We have seen that arc is part of the circumference. So we have seen that when you want to get the arcs are dividing the circle into either major or minor sectors. And the angle at the center can be expressed as the fraction of the whole circle. Remember now, we have seen that a circle can be divided into major and minor sectors. So at the center, we have the circle that is subtended by that arc. And that angle can be written as a fraction of the whole circle. But now what you're supposed to notice is that a full circle has an angle of 360 at the center. That is a full circle. But now when we consider a semicircle like this one, you have cut now the circle into 2 halves. The angle between here is 180 because you've cut the other half. So it is the angle that is subtended by this arc is 180. So when we want to write this angle as a fraction of the whole circle, it will be 180 degrees divided by 360 degrees. And when you divide, you'll find that this will be a half of the whole circle. So in this case, the arc length will be equal to a half of the circumference of the circle, which implies that if maybe the circumference was 44, and now you want to get the length of this arc, it will be a half of 44. But note is when we are considering the semicircle. Then from there, we have another part. If the angle at the center is 90, then the sector is 90/360 degrees of the whole circle. And therefore, if you simplify here, you'll get that it will be a quarter. So in this case, the arc length will be equal to 1/4 of the circumference of the circle. So in general, if the angle or at the center is theta, the angle that is subtended by the arc is theta, then the arc length is given by theta over 360 times circumference. Note that we are talking about 90/360 times the circumference. We have also seen 180/360 times the circumference. But this theta is the angle that is subtended by the arc. So simplifying, we can say that the circumference is 2 pi r, so it can be either theta/360 times 2 pi r, or remember the circumference is also pi d, so it can be theta/360 multiplied by pi d. Then from there we can move to examples. A circle has a radius of 18 centimeters. Calculate the length of the arc that subtends an angle of 36 at the center. We proceed as follows. we've seen that the arc length is given by theta over 360 to pi r. In our case here, we are given the radius, we are given the angle. So you just need to substitute the values in the formula. So theta is 36 over 360, then multiplied by 2, then multiplied by pi. In our case, we can use 3.142, then multiplied by 18, which is our centimeter or our radius in centimeter. And by so doing, when you multiply all these, you get that the value is 11.31 centimeters. Then question number 2. An arc of circle subtends an angle of 60 degrees at the center. Find the length of the arc if the radius is 42 centimeter. We are advised to use the pi as 22 over 7. So we proceed as follows. Always, we start by writing the formula. Arc length is theta over 360 times 2 pi r. Then you substitute the values. Our theta is 60. Divided by 360, then multiplied by 2, multiplied by pi, and multiplied by our radius. By 7, this one will go. By 7, here is 6. Then you can say that this one, by 6, 1 by 6, you have 6. Then you divide, and then you multiply, you get that the value is 44 centimeters. Note that this one you have to do it. Don't just say that it is 44. Make sure that you multiplied and then you divide, see whether you're getting the same value. Then from there, we have the third example. Find the angle subtended at the center of the circle by an arc length of 22 centimeter if the radius of the circle is 42 centimeters. So first of all, we write the formula. Arc length is theta over 360 times 2 pi r. But now we are given the arc length, which is 22 centimeter. We are supposed to look for the theta. So replace all the values that are given here. We are given the radius as 42. If you look at this, we need to make this the subject, or we write it in terms of the other values. So for us now to get, it means that we multiply 22 by the denominators, 360 times 7, so we have 22 times 360 times 7, and then we divide by the numerator. The numerators are 2 times 22 times 42. And by so doing, you can even cancel out. By 22 will go. Then by 2, you'll get 180. Then you continue cancelling out by 42. By 7, 1, by 7, 6, by 6, 1, you find that it will give you 30 degrees. So that way it means that you can be able to simplify. So I'm leaving it at this point so that now you can be able to cancel out. After arranging, make sure that you cancel out and you get the value as 30 degrees. Then from there, we have this fourth question. Find the radius of a circle if the length of the arc is 13.2 centimeter and the angle at the center is 240. So first of all, we write our formula. Arc length is equals to theta over 360 times 2 pi r. Then substitute the values that are given. You're given the arc length as 13.2. You're also given the degrees as 240. So we are looking for the radius. So we proceed just like the way we've done here. Now we write r. For you to get r, as you can see here, you need to multiply this value by the denominators. 13 times 360 times 7. Then you divide by the numerators, which is 240 times 2 times 22. Again, when you simplify, you'll find that the value of r will be 3.15 centimeters. From there, we move to example number 5. Find the perimeter of the shape. You have it here. For us to get the perimeter, we need to start from this point. You move, you move, you move. Remember, when we are talking of perimeter, it is the sum of the all outline. So now we are not considering the arc length. We want to get the perimeter. And for us to continue or to get the perimeter, it will be the arc length, then plus radius plus radius. So first of all, we get the arc length. The arc length is given by theta over 360 times 2 pi r. Our theta is 18 divided by 360, then multiplied by 2, multiplied by pi, multiplied by the radius, which is 7. And by so doing, you find that the arc length will be 2.2 centimeters. So our perimeter will be the arc length 2.2, then plus radius. Remember, we are adding everything here. So that way, when you get the sum, you get that the perimeter of this object or this figure or this shape is 16.2 centimeters. Then from there, we have another example. The figure below represents a flower garden. That is our flower garden. The garden is to be fenced all around using 4 strands of wire. So it has to be fenced all around. What length of the wire in meters is required? Now for us to get this, the length of the wire will be 4 times, because we are fencing 4 times, 4 strands times the perimeter. So the perimeter will be the arc length, then multiplied, added to the diameter. So the arc length will be theta over 360 and pi d. Our theta is 180. So it is 180 over 360, then multiplied by pi, then multiplied by the diameter. And by so doing, you find that this will be a half, then by 2, 1 by 2, 2. This is a half, then by 2 you have 11, then by 7 here, by 7 here you get 2, so you get by 22. So I'm saying make sure that you divide here. That is the only way you will practice. Practice and make sure that you get the value that is given here. Then from there, to get the perimeter, you just need to add the arc length, then plus the radius, the diameter. And the diameter here was given as 14 centimeters. So the perimeter will be 36 centimeters. So the length of the wire will be 4 times the perimeter. So that will be 4 times 36. You get that the wire that is required is 144 centimeters in length. Then question number 7. A circular plot was fenced by 2 equal strands of wire whose total length was 440 meters. What is the radius of the plot? And you're supposed to get the pi as 22 over 7. Now in here now, we are given the length of the wire. So we can be able to get the circumference, because now we are told that this wire is used to fence using 2 equal strands. So our circumference will be length divided by 2, because the length of the wire will be twice times the circumference. So 440, which is the length of the wire, will be twice the circumference, and therefore our circumference will be 440 divided by 2, which is 220 meters. But this one is equivalent to 2 pi r. Remember, this is the formula of getting the circumference. So 220, now you replace 2 times pi, then times r. Remember, we are getting the r. So to get the r, you multiply by the denominator, 220 times 7, and then you divide by the numerator, which is 2 times 22. And that way, when you simplify, you get that the radius will be 35 centimeters. Again, make sure that you cancel out like that. This one is easier. By 22, 1, by 22, 10. So it will be 10 times 7. You get 70 divided by 2, you get 35. So make sure that you practice a lot. So from there, we have the assignment. Again, make sure that you practice a lot before you come to do the assignment. And finally, prepare for the end of topic exam. So thank you, and let us meet in another topic.